Okay, let me submit the test first, make sure it shows the answers. I'm in preview mode here, and I just want to make sure that okay, that's not a good one. Okay, yeah, this will show it. Okay, so let me preview this. And I'll go ahead and take it. Okay. Telephone company offers 2 billing plans for local calls. Plan 1 charges $22 per month for unlimited calls. Yeah, get there. There we go. So we got plan 1, and we got plan 2. $22 per month for unlimited calls, and plan 2 charges $18 per month plus 4 cents for per call. This per call kind of tells me I'm going to take this 4 cents times X. Using inequality to find a number of monthly calls for which plan 1 is more economical than plan 2. More economical. That would tell me that plan 1 is less than plan 2. Won't be equal to, because more economical means it can't be the same. Okay, so plan 1 is $22 per month, are made each month. Okay, so I don't need to multiply 22 times anything since it's per month and we're looking for each month. And then plan 2 charges $18 plus 4 cents per call. I want to make sure I put that into dollars. So 4 cents is 0.04 times X. Using an inequality to find number of monthly calls for which plan 1 is more economical. Okay. Here I'm going to take the 18 over. So I got 22 minus 18, which gives me 4. Then I'll divide both sides by 0.04. And not very good decimals. Let me grab a calculator here if I brought one. Yeah, I did. So, I got 4 divided by 0.04. That's strange. 100. And here these 0.04s cancel. Now I can flip this around, and this would be x is greater than 100. If more than 100 calls are made. Just curious. This is check answer here. Okay. Now here, x is greater than negative 4. For our inequalities, if you got x is greater than a number or x is less than a number, in this case x is greater than negative 4, what you do is you first pretend that it's x equals negative 4 and you graph that. Now x equals negative 4 is a vertical line at negative 4, and since there's no line underneath here, it'll be a dotted. Now if there was a line underneath, like it'd look like x is greater than or equal to negative 4, then I would have made this a solid. And greater than, I'm going to shade to the right. Let's see. Click to enlarge graph. My line tool, I want a dotted or dashed line here, and I want the line. I choose negative 4, and I'll choose somewhere up here. And my shading tool, shade to the right, and then save. And check answer. Okay, let's take a look at this one. got absolute value of x plus 1 plus 1 is greater than or equal to 8. Now first off, we have to get the absolute value by itself. So I'll subtract 1 from both sides. So I got plus 1 minus 1, and over here I got the minus 1. So we got the absolute value of x plus 1 is greater than or equal to 7. Now this is a greater than case. And what's inside our absolute value will be our p, and the other side will be our q. And our formula for the greater than case is p is less than or equal to negative q. There's no or here, and p is greater than or equal to a positive q. Now if you have a line underneath here, then you have to put line underneath the formula. Now everywhere I have a p, I'll plug in x plus 1, and everywhere I have a q, I'll plug in 7. So I got x plus 1 is less than or equal to negative 7. There's no or. And x plus 1 is greater than or equal to positive 7. Now here I'll take the 1 over. And we got x is less than or equal to negative 8. And here I'll take the 1 over. And we got 7 minus 1, which is 6. Now they want it in interval notation. So less than goes to negative infinity. Specifically, it's a less than or equal to. When you got the line underneath there, you put a bracket on this. And then a union symbol in between them. Greater than goes to positive infinity. Infinities always have parentheses. And there's a line underneath, so that'll be a bracket. So, one or more intervals. This one right here. Type your answer in intervals. Simplify your answer. Use integers or fractions for any numbers in the expressions. Okay. So we got beginning parentheses, negative infinity, comma, negative 8, bracket, the union symbol, and the bracket, 6, comma, positive infinity, and then parentheses. Now the graph. I know it can't be b because those are parentheses there, and we've got brackets on the negative 8 and 6. Can't be this because it's not shaded. Won't be this. Won't be this. Won't be that. Has to be a. Because x is less than or equal to negative 8. Well, here's negative 8, and it's shaded to the left, less than, and it's a bracket on it. And x is greater than 6. Well, 6 shaded to the right, bracket on it. Now graph this inequality. Okay, we got 4x minus 3y is less than or equal to 24. Now, we pretend that this is 4x minus 3y equals 24. We pretend the inequality is an equals. Now we graph this. Probably the intercept method's the easiest. For the x-intercept, I'm going to plug 0 in for the other variable, so I'll plug 0 in for y. So I got 4x minus 3 times 0 is equal to 24. 4x equal to 24, or x is equal to 6. Now our y-intercept. You plug 0 in for the other variable, so we'll plug 0 in for x. So I got 4 times 0 minus 3y is equal to 24. 4 times 0 drops away. And we got negative 3y is equal to 24. Divide both sides by negative 3, and you get y is equal to negative 8. Now specifically, this has a line underneath. Line underneath means it's a solid line. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Well, let's go draw our line first. What did I say? 6 was my x-intercept. So I'm going to do a line. There's 6. and negative 8. So come down here, negative 8. Now I'm going to either shade one side or the other. And how you can determine which side to shade is you pick a test point. Now your test point can be any point. It just has to be definitely on one side or the other. I'll choose 0, 0. That's almost a perfect one to pick. So we'll plug that back into our original inequality. So I got 4 times 0 minus 3 times 0. And we're wondering if that's less than or equal to 24. That's a question mark at this point. 4 times 0 is 0, minus 3 times 0, that's 0. So we get 0 is less than or equal to 24, which is true. Now since it's true, we're going to shade the side where that point falls. If it was false, we'd shade the other side. So over here, I'll choose my bucket tool, and I'll shade this side. Click Save, and check Answer. Solve the compound inequality using the graphing utility screen. y2 is greater than or equal to y1, or y2 is less than or equal to y3. Yeah, I can't get it over there. What if I grab the edge? No, don't let me grab the edge. Okay, y2 is greater than or equal to y1. Here's y2. Greater than or equal to y1 would be here. 1, 2, 3, 4, 5, 6, 7, 8. Let me close that. Negative 8. 1, 2, 3, 4, 5, 6, 7, negative 8, and okay. Trying to figure out what in the world, because when you zoom it, it looks like 8 zeros over here, but they really mean for this to be 8, 0. Okay, that's making more sense then. Now the we're looking where y2 is greater than or equal to y1. Well, you can visually see this. Maybe if I make it bigger, I can visually see it. Okay, here's y2 down here. So this y2 is this line here, and we're looking where that's greater than y1. Okay, and what's the other condition? Or y2 is less than or equal to y3. Well, y2 less than or equal to is over here. So let me erase this. Now you're looking for where which one's graph is above or below the other one. So y2 being less than or equal to y3 is this piece right here, which is coming from negative infinity, and then it stops at negative 8. And then bracket, and then union, and then where y2 is greater than y1 is right here, because here's y1, and greater than or equal to would be up here, so that's from 8 on. Now they're brackets because it says greater than or equal to and y unequal to. Okay, so negative, negative infinity, negative 8, union, 8 to positive infinity. Now the or in mathematics is always a union. If it said and, that's the intersection. So a little bit. That one's a little bit confusing if you zoom it. Okay, graph the intersection of x minus y is less than 4 and x is greater than 2. Okay, we got x minus y is less than 4, and we got x is greater than 2. Now first off, let's just do x is greater than 2. That's a greater than, there's no line underneath, which means this is a dashed line, dotted line. And greater than means I'm shading to the right. So it looks like that. Now if I graph this other one, and I could do it different ways, but first off I have to pretend it's x minus y is equal to 4. And if I take the negative y to the right side and the 4 to the left, I get x minus 4 is equal to y. Now my m is whatever number is in front of your x, which is 1, and your y-intercept is the number at the end, which is negative 4. 2, 3, 4, so it's right here. M is 1, which is 1 over 1, which means I'll go up 1 and right 1, and that would be my next point. And this will, since there's no line underneath here, this will be a dashed line again. Now, we're going to look at x minus y is less than 4. We want to pick a test point. Let's say I pick the origin, because I know the origin's on this side of this line. So I'll plug in 0, 0. So I got 0 minus 0. We're wondering if that's less than 4. And 0 is less than 4, so that checks, which means we want to shade that side. If it didn't check, we would want to shade the other side. Well, first off, let's plot our lines. See, dashed lines, and one's at 2, like that. And the other one was at negative 4, and then I went up 1, right 1. Negative 4, up 1, right 1, like that. And then my shading tools where our answers where they're both shaded, which is up here. And save, and check answer. Okay, let's take a look at this one. Let me erase this. We got absolute value of 2x plus 2/3 minus 6 is less than or equal to negative 3. Well, first off, we have to get the absolute value by itself. So I'm going to take the negative 6 and move it over. We get the absolute value of 2x plus 2/3 is less than or equal to negative 3 plus 6. You take anything across your inequality, the sign changes. Negative 3 plus 6 is 3. And now this is in the right form. This is a less than case, specifically less than or equal to. What's inside our absolute value will be our p, the other side will be our q. Our formula says we're going to plug it in negative q is less than or equal to p is less than or equal to positive q. So everywhere there's a q, I'll plug in 3. So I got negative 3 is less than or equal to, and everywhere there's a p, I'll plug in 2x plus 2/3. Now we want to solve for x. You want to get x by itself in the middle. First step, get rid of parentheses, don't have any. Second step, get rid of fractions. Multiply everything by the LCM of all your denominators. We only have one denominator, so that is our LCM. So we'll take 3 times negative 3, 3 times 2x, 3 times 2/3, and 3 times 3. It gives us negative 9 is less than or equal to 3 times 2 is 6x. And those 3's cancel. We got plus 2 is less than or equal to 9. You could either subtract 2 from all 3 sides or just take the 2 over. So we got negative 9 minus 2 is less than or equal to 6x is less than or equal to 9 minus 2. Negative 9, negative 2 is negative 11 is less than or equal to 6x is less than or equal to 9 minus 2, which is 7. And then divide both sides by, or all 3 sides by the number in front of your x, which is 6. And we come up with this answer. They probably wanted an interval notation. Interval notation, which means bracket negative 11/6, comma 7/6, and then bracket. Okay, so bracket negative 11/6, comma 7/6, and then another bracket. Okay, graph-wise, I want shaded in between negative 11/6 and 7/6 with brackets on both of those. It's definitely not that one, not that one, not that one. I don't know what these numbers are, but that seems reasonable. Negative 11/6 to 7/6. I don't think there's any way to zoom to see that a little bit better, but oh well. Let's take a look at this one. Let me erase this. Okay, we got 8x minus 6 is less than or equal to 7x minus 1. This is a linear inequality, so we'll solve it first. Get everything with an x on one side, numbers on the other. So I'll take the 7x to the left side, becomes a negative 7x. I'll take negative 6 to the right side, becomes a positive 6. 8x minus 7x is 1x or x, and negative 1 plus 6 is 5. And then to graph it, line underneath here means put a bracket on the 5, and it's less than, so it's shaded to the left. Let's see, choose a correct graph. 5, this should be this one. Select the correct choice, and if necessary, fill in the answer blank. Okay, solution set. Type your answer in interval notation. Less than or equal to 5, that goes to negative infinity. Infinities always have parentheses on it, and there's a line underneath on the 5, so we'll put a bracket. Negative infinity, comma, 5, bracket, and check answer. Okay, number 9. You cannot have an absolute value equal to a negative number, so there is no solution. Solution set is the empty set. This is another oddball case. Got the absolute value of x plus 8 is equal to the absolute value of 9 minus x. Now how you treat this absolute value case, this oddball case, is you drop one of the absolute values. Doesn't matter which one, it's your choice. And then at this point, it's an absolute value of something is equal to something else. So what's inside of our absolute value would be our p, and the other side would be our q. And our formula says we're going to have p is equal to q, and p is equal to negative q. So I'll plug in what I've identified. We got x plus 8 is equal to 9 minus x, and x plus 8 is equal to negative 9 minus x. Now notice when I put the 9 minus x down here, I put parentheses around it, because this negative that's out in front has the flip sign of everything and follows it. And over here, I'm going to get everything over on all the x's on one side, numbers on the other. So I take this negative x over, it becomes a positive x. And I take this 8 over, and it becomes a negative 8. X plus x is 2x, 9 minus 8 is 1, which gives us x equals 1/2. Now over here, the negative will flip the sign of everything inside, so that becomes a negative 9 plus x. Get everything with an x on one side, numbers on the other. So we get x minus x equals negative 9 minus 8. Again, when you take anything across your equals, your sign changes. X minus x is 0x or 0. Negative 9, negative 8 is negative 17. Notice that the x disappeared. Well, when is 0 equal to negative 17? Well, never. So we cross that one off. And our only answer is x equals 1/2. Solution set. Type an integer or use comma separate answers. Okay, there's curly brackets here. So they want just the 1/2. Let me grab a drink here. Solve the compound inequality. Well, this is kind of weird. There's nothing to solve. Let me clear this off. And we got x is less than or equal to negative 1. And there's an or, and x is greater than or equal to positive 1. First off, let's graph it. Less than or equal to negative 1. Since there's a line underneath, that means bracket. And less than means shaded to the left, so it looks like that. Again, this one has a bracket because of the line underneath, and greater than is shaded to the right. So this one would look like A, I guess. Now write it in interval notation. This interval here is from negative infinity to negative 1, bracket. Again, clear over here is negative infinity. Bracket on negative 1 here, bracket on negative 1 here. Clear over here is positive infinity, so this will be 1 to infinity, parentheses on infinity, and bracket on 1, and then a union symbol in between them. So we got negative infinity, negative 1, bracket, and then we want a union, then bracket 1, and then positive infinity. There we go. That's another weird, another one that it's already solved. No work to be done. Besides just writing it different forms. X is less than 2. I think it says or. No, and. X is greater than negative 1. Let's first graph it. Negative 1 is over here. And x is greater than negative 1. It's a parentheses since there's no line underneath. And greater than is shaded this way. Now the other one is a positive 2, which we'll say is right here. And it's a less than, so there's no line underneath, so it'll be a parentheses again. And less than is shaded this way. Now our answer is where they're both shaded. So it'll be from negative 1 to 2. So it'll look like that. Negative 1, 2, I'm guessing B. That's the only one even looks close. And then to write this in interval notation, parentheses on negative 1, parentheses on negative 1, parentheses on 2, parentheses on 2. And that would be our answer. Let's see, negative 1, 2. So far, I've got every one of these right. That's a good thing. What's this? Linear equation looks like. Let me clear this off. And we got 4 times p minus 8 minus 3 times 2p plus 5 equals 2.5 times 2p minus 13. Now, first step, step 1, get rid of parentheses. We're going to use the distributive property, so I'll take 4 times p, 4 times negative 8. That gives us 4p minus 32. We'll take negative 3 times 2p and negative 3 times 5. Negative 3 times 2p is negative 6p. Negative 3 times 5 is negative 15. And here I'll take 2.5 times 2p and times negative 13. I think that's 5p. 2.5 times 2. Let me grab my calculator. Not very good with decimals. Oops. 2.5 times 2. 5. Okay. And 2.5 times 13. 32.5. So that'll be a minus 32.5. Now combine like terms in a step. 4p minus 6p is negative 2p. Combine numbers. Negative 32, negative 15 is negative 47. Step 2, get rid of fractions. Don't have any. Step 3, get everything with a p on one side, numbers on the other. So I'll take 5p over here. And I'll take negative 47 over here. Remember, when you take anything across your equals, your sign changes. So 5p becomes a negative 5p. The negative 47 becomes a positive 47. Combine like terms. Negative 2p, negative 5p is negative 7p. And negative 32.5 plus 47, 14.5. Then divide both sides by the number in front of your p. And 14.5 divided by negative 7. Bunch of decimal places. Type in integer or decimal rounded 2 decimal places. Okay. Negative 2.07, 2 decimal places. Let me double check that. 4p minus, okay. Negative 6p minus 15. Okay. Negative 2p minus 47. It just seems so weird. Negative 2.07. Type in integer, rounded. There's no curly brackets here, so I'm assuming they don't want the p equals. They just want negative 2.07. Okay, let's take a look at this one. Let me clear this off. X minus 3 over 3 is equal to the absolute value of negative 5. Now you might think this is one of those oddball cases where since both sides got an absolute value on them, we can just drop one side. But this is just a single number here. So this actually becomes absolute value of a negative number becomes a positive number. So then what's inside is our p, the other side is our q, and our formula is p is equal to q and p is equal to negative q. So everywhere there's a p, I'll plug in 2x minus 3 over 3. Everywhere there's a q, I'll plug in 5. Now I want to solve these. These are linear equations. Step 1, get rid of parentheses, don't have any. Step 2, get rid of fractions. Multiply everything by the LCM of all your denominators. So I'll multiply both sides by 3. And those 3's cancel. We got 2x minus 3 is equal to 15. Take the negative 3 to the right side and it becomes a positive 3. And we got 2x equals 18, or divide both sides by 2 and we get x equals 9. Same thing here. We want to multiply both sides by 3. And those 3's cancel. And we got 2x minus 3 is equal to negative 15. Take negative 3 over. Becomes a positive 3, which gives us negative 12. And then divide both sides by 2 and you get negative 6. So 9 and negative 6. Okay, solution set. Type in integer, simplified fraction, use comma, separate the answers as needed. Negative 6, comma 9. And 15. Let me erase this. Now we have 7 times x minus 6 is less than 2 times 4x minus 1. And it says solve the following inequality. Write it in interval notation. Well, first step, get rid of parentheses. Use the distributive property. Take 7 times x, 7 times negative 6, 2 times 4x, and 2 times negative 1. 7 times x is 7x, 7 times negative 6 is negative 42. It's less than 2 times 4x is 8x, and 2 times negative 1 is negative 2. Step 2, get rid of fractions. Don't have any. Step 3, get everything with an x on one side, numbers on the other. So I'll take the 8x over the left side and negative 42 to the right side. Remember, when you take anything across your inequality symbol, the sign changes. Always combine like terms. 7x minus 8x is negative 1x. Combine numbers. Negative 2 plus 42 is 40. And then last step, divide both sides by number in front of your x. So divide both sides by negative 1. Now when you divide by a negative, you flip your inequality symbol. So less than becomes a greater than. So we got x is greater than negative 40. And with no line underneath, so we use parentheses. Negative 40 to positive infinity. Okay, negative 40 to positive infinity. Check answer. Okay, here's an absolute value equation. Let me clean this off. And we got 5 minus 7x is equal to 16. Now it's already in the right form because the absolute value is by itself on the left side. So what's inside our absolute value will be our p, and the other side will be our q. And our formula says p is equal to q, and p is equal to negative q. So everywhere there's a p, I'll plug in 5 minus 7x, and everywhere there's a q, I'll plug in 16. So I got 5 minus 7x equal to 16. 5 minus 7x equal to negative 16. Now I want to solve for x. So here I'll take the 5 over. So we got negative 7x equal to 16 minus 5. 16 minus 5 is 11. And then divide both sides by negative 7. And you got x is equal to 7 over negative 11. Now here I'll do the same thing. Take the 5 over. So I got negative 7x equal negative 16 minus 5. Negative 16, negative 5 is negative 21. And then divide both sides by negative 7. And we're going to get x is equal to positive 3. So, negative 11 over 7 and 3. Solve the equation algebraic and graphically. Okay. We have 7x minus 14x plus 4 is equal to negative 7x plus 4. Now the negative that's in front of this parentheses flips sign everything inside. So we got 7x minus 14x minus 4. And this negative flips sign everything inside. So we got negative 7x minus 4. Combine like terms. 7x minus 14x is negative 7x minus 4. That's curious. Get everything with an x on one side, numbers on the other. Remember, when you take anything across or equals, your sign changes. Negative 7x plus 7x is 0x or 0. Negative 4 plus 4 is 0. What this means is it's an infinite number of solutions. When you come up with something that's always true, like 0 is equal to 0, 5 is equal to 5. So how do you represent that? I guess negative infinity, positive infinity, if I had to guess, since it's interval notation. Or is it interval notation? Oh. Solutions all real numbers. Now it's the same line is what that represents. So on A, see how it looks like we just have one line? That's because one line falls on the other line. There's an infinite number of solutions. Now B, see how they intersect at one point? C, see how they intersect at one point? These are both where you come up with an answer, like x equals 5. And if you got parallel lines like this last one, what does that mean? No solution. They don't intersect at all. The other one is a little tricky. I have to think about that. I was expecting it to be a normal one. Now here we got 3x is greater than or equal to 7, or negative 5, 6 x minus 1 is greater than 3. And okay, I want to solve it. I'll solve each one of these separately first. So here I'll divide both sides by 3. And we got x is greater than or equal to 7/3. Now over here, step 1, get rid of parentheses, don't have any. Step 2, get rid of fractions. Multiply everything by the LCM of all your denominators. We only have one denominator, so that's our LCM. So we'll take 6 times negative 5, 6x, plus 6 times negative 1 is greater than 6 times 3. Now 6's cancel. We got negative 5x. 6 times negative 1 is negative 6. And 6 times 3 is 18. Take negative 6 to the right side. So we've got negative 5x is greater than 18 plus 6. 18 plus 6 is 24. And then divide both sides by negative 5. And remember, if you divide by a negative number, you have to flip your inequality symbol. So this becomes x is less than negative 24/5. Now here's negative 24/5 less than, would look like that. Here's 7/3, and greater than or equal to would be a bracket here, and greater than is that way. So this, interval notation wise, would be negative infinity to negative 24/5. Parentheses on that because there's parentheses up here. Union, bracket on 7/3, bracket on 7/3 to positive infinity. Beginning parentheses, negative infinity, comma, negative 24/5, and parentheses, union, and bracket 7/3, comma, positive infinity, and then close parentheses. Let's take a look at this one. Let me clear this off. Okay, we got 1 is less than or equal to 1/2 x plus 9 is less than or equal to 8. Now this is solving a compound inequality with 3 sides. The first step is get rid of parentheses, don't have any. Second step, get rid of fractions. Multiply everything by the LCM of all your denominators. We only have one denominator, so that's our LCM, so multiply everything by 2. 2 times 1 is 2. It's less than or equal to. Those 2's cancel, and I got x. 2 times 9 is 18, and 2 times 8 is 16. Now take this 18 and take it over the other 2 sides. That's equivalent to subtracting 18 from all 3 sides. So I got 2 minus 18 is less than or equal to x is less than or equal to 16 minus 18. So that gives us negative 16 is less than or equal to x is less than or equal to negative 2. Now these both have lines underneath, so be a bracket, and be a bracket over here also. And it's between those 2 values, so we have right in that form. Negative 16, what in the world did I just put? Negative 16, comma, negative 2. Y is less than or equal to 1. So y is less than or equal to 1. Now first off, we pretend it's a y equals 1 and graph that. Y equals a number is a horizontal line at that number. Now specifically, since there's a line underneath here, this will be a solid line. If there was just less than 1, we would have a dotted line. And since it's less than, we're shading down here. So that'd be our graph. Okay, so solid line at 1. Y equals 1, not negative 1. About made my first mistake. There we go. And then a shade down below. Save and check answer. And last problem. Let me come over here and clear this off. We got 4 minus x is greater than 8, and 3x plus 1 is greater than or equal to 13. Now we want to solve for x, so here I'll take the 4 over, and it becomes a negative 4. We got negative x is greater than 4. Divide both sides by negative 1, and when you divide by negative 1, you flip your inequality symbol. So this becomes x is less than negative 4. Now here I'll take the 1 over, becomes a negative 1, which gives us 12, and then divide both sides by 3. And we got x is greater than or equal to a positive 4. Now here's negative 4, less than is shaded this way, and it's parentheses since there's no line underneath. Here's 4, and it's shaded this way. Now when you have an and, your answer is where they're both shaded. Well, there's no place where they're both shaded, which means solution set is empty set. And submit the test. And that would be that particular test.